Hey guys, welcome to Career Capsule. A powerful earthquake has struck Myanmar, leaving behind a trail of devastation. What makes this quake so significant, and why did the neighboring regions like Bangkok feel its tremors? Let's break down the science behind this seismic event. The story so far we know that a powerful earthquake in Myanmar on March 28th had its source in central Myanmar, about 20 kilometers away from Mandalay, which is country's the second largest city. Mandalay is located on the east bank of Irrawaddy River, which is close to the one of the most seismically active faults in the region, called the Sagaing fault. This is named after a town which is not far away from Mandalay on the river's opposite side. The earthquake of magnitude 7.7 struck around 12:50 pm local time, which was followed by several strong aftershocks, which includes a magnitude of 6.4 occurred 11 minutes after the major event. This has impacts and some damage assessments were made. The quakes were very devastating. They affected the entire region, left thousands of people dead, and destroyed many homes as well. The damage zone extended to Bangkok, the capital of neighboring Thailand, which is about 1000 km from the earthquake's epicenter. However, the damage in Bangkok was minimal, confined to the complete collapse of a 33-story under construction high-rise building and causing the water from a swimming pool on the top of the another high-rise building to overflow. However, these incidents were given much hype because of the city's place on the global tourism circuit. The outpouring of water from the rooftop pool was due to seismic seismic oscillations in the water triggered by the passage of seismic waves through the area. Even though the building was located far away from earthquake's source, the long period seismic waves can cause the top floors to sway more and amplify the seisches. The damage prediction models of the US Geological Survey, which estimated that the total death toll in the region could reach well over 10,000. Mandalay itself is a home to over 1.5 million people and was hit hardest, with many buildings including pagodas, mosques, bridges partially damaged or completely collapsed. A review of the damage pattern reveals that much of the devastation was concentrated in the southern area of Sagaing fault because this region is sitting on the thicker pile of alluvium deposited by the Irrawaddy River, which amplifies the seismic energy as compared to the northern parts of the fault. This also explains why China's southwest Yunnan province, which is north of the fault, escaped earthquake induced damage. The depth to the source of 2025 earthquake on the Sagaing fault was only 10 km, which is another contributing factor for the heavy damage and the large felt areas, the area where the earthquake shakings felt. Are the quakes common in South Asia? We have some of the Asian parts where including the Myanmar, which is highly prone to earthquakes due to its proximity to the complex assemblage of some of the largest tectonic features on the earth, including the Himalayas, the Shillong Plateau and southern Indo-Burman range and the Andaman Nicobar subduction zone. Originating from the collision of the Indian and the Eurasian plates some 40 million years ago, the plate boundaries in the Southeast Asia is an active tectonic feature that generated one of the largest earthquakes in history of magnitude 9.2 and a transcontinental tsunami in 2004. The tectonic stress accumulating on these plates boundaries is the cause for frequent seismic activity in the region. What is that? The tectonic stress accumulating on these plate boundaries is the cause of the frequent seismic activity in the region. The earthquake of 1792 was also a great megathrust, which is an earthquake of magnitude 8.5, with its epicenter located somewhere along the Arakan coast of Myanmar. This seismic event generated a tsunami in the northern Bay of Bengal and caused widespread soil liquefaction in the Chittagong areas of Bangladesh as well. The large thrust fault extends further north onto the Chittagong Tripura fold belt also, where several moderate earthquakes continue to occur. It is still not clear whether this part of the deformation front can generate future great earthquakes. The Southeast Asia is a tectonic museum that exhibits structures that host earthquakes of varying faulting mechanisms occurring at depths ranging from as shallow as 5 km to 200 to 400 kilometers deeper. The deeper ones occur in the southern regions, which are closer to Indonesia, or the Indo-Burmese regions in the north. This is bordering the subduction front along the Indo-Eurasian plates. The 2025 Mandalay earthquake in central Myanmar was sourced from within the continental part of the mountain range itself. In the tectonics of mountain building, such features develop when sediment piles up and rocks are scraped off from the subducting Indian plateau, which get plastered onto the overriding Asian plate. The geodynamic context of the Sagaing fault. Because of the complex interplay of plate motions and the resulting geodynamics in the eastern margin of the Indian Ocean, the northeast directed convergence of the India and Eurasia plates takes place in this slanted fashion rather than happening head on. This oblique convergence of the plates causes the overall strain to become partitioned, with the part of the deformation being perpendicular to the plate boundary and the other part occurring parallel within the interiors. The north-south running Sagaing fault forms the tectonic boundary between the central Myanmar lowlands and the Indo-Burman range. An elongated microtectonic block that exists between the Indian plate and Sagaing fault is commonly called as the Burma plate or the Burma sliver. It owes its origin to the strain partitioning occurring at the subduction front. Studies have revealed that this fault with the subsidiary parallel structures, which accommodates much of the strike slip, a part of the oblique convergence, with a slip rate of 15 to 25 mm a year and an accumulated slippage of 100 to 700 kilometers. The Sagaing fault accommodates about 50 to 55% of the overall plate motion in this region. Unlike the vertical motions of fault blocks along the frontal part of the convergence zone, where the one tectonic block is pushed up on the other, the movement is horizontal on the Sagaing fault, with the blocks sliding past each other. The San Andreas fault in the western US is another such example. Unlike thrust faults, where the earthquakes originate at either shallow or deeper sources, earthquakes on strike slip faults are almost away shallower than 10 to 15 kilometers. This is classified as a A typical ridge trench transform fault. The Sagaing fault system runs 1400 km between the spreading center under the Andaman Sea in the south to eastern Himalayan bend in the north. It has a long history of earthquakes, moderate and occasional strong earthquakes of magnitude 7 and above are common in this central Myanmar, where such six strong earthquakes of 7 magnitude or more they had been struck between 1930 to 1956 along the Sagaing fault or the adjacent structures. Analysis of historical earthquakes have revealed that about half of the Sagaing fault has ruptured in the last few decades. Thus, the 2025 earthquake is not a surprise event, but a part of the earthquakes occurring subsequently on the structures to release the accumulating stresses from the ongoing active plate interactions. The historical records support that the occurrence of the earthquake in 1839 called the Awa earthquake that killed more than 500 people in central Myanmar. This event may have originated on one of the segments of the Sagaing fault with a hypothesized magnitude of 7.8. Equal interesting is the earthquake of 1927 reportedly felt strongly north of Yangon, Myanmar's largest city, with a current population of more than 4 million people. Records also indicate that an earthquake occurred in 1946, possibly on the Sagaing fault north of Mandalay, with a over of 7.7 magnitude, like that of current 2025 Temblor. The historic city of Bagan in the central Myanmar, densely packed with religious monuments, that has also been subjected to several damaging earthquakes. The latest one to hit this town was in 2016. The science helps us understand the processes behind this earthquake and provides approximate locations of future earthquakes as well and their possible magnitudes. The Sagaing fault is not merely a scientific curiosity. It has a tragic impact on the millions who live with the restless fault beneath their feet. Myanmar is struggling to cope up with the aftermath of latest earthquake with a rising death toll and extensive damage to the infrastructure, both complicated by the ongoing civil war as well. The lessons for India, we can say we have to recognize the vulnerability. Most earthquake prone country in South Asia, we have to implement safety measures as well. Scientifically tested construction standards needed to implement these safety measures. We have to prepare an emergency response system to develop a mitigation procedures. Then we have to educate the citizens about earthquake preparedness by increasing the public awarenesses. This way we can reduce the damage if anything like this happens in India. That's all for today. Hope you have understood why this Myanmar had this much of a strong magnitude of earthquake. Thank you.